Yeah, so welcome everyone to our Global Medical Physics Education Lecture Series. We are very lucky to have Paul Naine here from Mirion Medical. He recently gave a similar version of this talk as the keynote speak at the WIMP meeting. So it is a little different than other lectures that have been given in this setting, but I think that's what will make it super interesting. And Paul has a unique experience in his career working mainly in industry and will share some of his perspectives. So I will turn it over to you, Paul.
Thanks, Joe, and really appreciate it, guys. And just a little bit of housekeeping from me, first of all. Um, I just said this to Joe. I don't know if everybody can hear me, but if you've got any questions, probably hold them to the end because I can't see the chat window at the moment if I'm presenting. So I'd really appreciate that. The second thing is an apology. I'm in Atlanta, Georgia, and it is raining pollen. So if I have to pause and just cough or clear my throat a little bit, that's why, and I apologize for that in advance. But with that said, let's dive in. And Joe, like honestly, thank you so much for the opportunity to speak. To to yourself, to the rest of everybody online, and to Rad Aid in general for two things. Number one, for allowing me this time to speak with you guys, but also for all the other fantastic work that you do. You were just mentioning you were heading to, I think it was Nigeria next week. So, we wish you safe travels and an impactful workshop there for the incredible work that you guys do. Um, but I wanted to say thank you to all of you guys who are choosing to spend your next 30 or 40 minutes here on this call listening to me. And I can't express how weird and how humbling that is for me sometimes to be able to share, for people to choose to share that time with me. So um, I really do appreciate it, and I do hope to make it worthwhile, whether you're watching live or you're watching a recording. I will do my absolute best to make this a good choice of how you spend your time. I know it's valuable. Um, so I kind of wanted to jump in and say today's talk might be a little different to other talks in this excellent Rad 8 lecture series, because today our goal is not to cover a specific treatment modality, whether from a clinical or academic perspective, and we won't be talking about task group reports or clinical efficacy. Today's talk is a little bit different. It's some observations, it's some thoughts, but mostly it's really a question. Let me just advance the slide. Okay. Um, and really, kind of, I want to start with a question. I'd like to start with each one of you asking a very simple question. Why should I listen to this guy? Why should I listen to Paul? And perhaps that's an odd way to start a talk. Public speaking guidelines say the first thing I should do is establish authority in the field in which you're about to speak, to provide the why should you listen to me. But even that, I encourage you to question. There are some subjects we're going to touch upon today where I absolutely am not the authority in the field. And perhaps, as my wife regularly assures me, I'm probably wrong, right? So let me provide some information for you to base your judgments. Starting at the beginning, I was born in Mauritius, and I've had an incredible privilege to grow up and live in many parts of the world: Africa, Middle East, Europe, Asia, and then I ended up in North America. Academically, I've studied engineering and medical physics, and career-wise, for almost 20 years, I've worked at companies like Electa, both variants, and I'm currently employed by Sun Nuclear, a Mirion company. On that note, I do want to be very clear that today's talk isn't a Sun Nuclear or a Mirion talk. In fact, it reflects my own views, and it has not been endorsed or processed by my current employer at all. So for the next hour, please just consider me very simply Paul. Uh, Basically, that's the legal disclaimer. Everything you see at the bottom of emails, just think of that. Personally speaking, I'm 42 years old, and I live in Atlanta, Georgia, with my wife and two kids who are 3 and 5 years old. And I raised that for a reason. Today is a bit of a story, because if you think back 5 years, we're back at the start of the pandemic, and the world was starting to change quite a lot. And I'm not going to be able to see this because I can't see the screen, but I would like for everybody else to have a look. If I'd like to get a digital show of hands at this point to the very generic and non-scientific question of, do you think things are a little bit weird right now? And if you're watching on the recording, maybe just comment me or something like that We'll take a selfie holding your hands up. But if you raise your hands and you think things just feel a little bit odd right now, and while we're waiting for some hands, I wanted to reflect with you guys. For me, in all honesty, the last 5 years have been kind of tricky. Delineating between the world changing in general and what for me personally was a parenting change, that was actually quite tricky. So today is very much a personal story. It's a story of how one person has tried and is still trying to figure out what changed, what is changing, and frankly, how to contribute meaningfully to a changing world. All right. I can't see your hands, but I'm going to look later. So actually, somebody just texted me and said there's quite a few hands up. So I appreciate your participation and thank you for the text. So you can lower your hands now, but we are going to come back to that question towards the end of the talk. Um, and I know it's a blank screen, it's supposed to be, but just bear with me on this one. I won't be following public speaking rules, right? So today's talk is not an answer. There is no hypothesis, there is no experimental procedure or results or conclusion. There aren't even references for today's reflections. It could be complete nonsense. So you're probably thinking, crikey, so what is today? What's the talk about? Well, it's part rambling observations, it's part therapy session, but mostly it's just one confused human sharing some thoughts with other, maybe a little bit confused humans, in an effort to be more human. We're going to look at what changed in the world and how it's impacted us. Not not just us as a field, but you specifically. I hope that some of this talk can speak to you directly as an individual. I will break all the invited speaker rules and not establish expertise in the area, but barely going to speak about the agreed upon subject. We're going to discuss money, and of course, there's going to be a little bit of politics just to break every single rule you can in public speaking. Um, so things have truly changed. The world does feel a bit odd. And as a physicist, like many of you, I wanted to understand why. Actually, that's kind of wrong, right? I needed to understand more. The rules of the world seemed to change. The power of fact seemed to give way to the power of perception. Huge socio-economic splits took place. Conflict engulfed entire regions, stock markets were soaring, blueberries cost $9, Tiger King became a thing on Netflix, and everybody started baking sourdough. At this point, please make it make sense, right? Genuinely, I needed for this to make sense just for me to function. So, like any good scientist, I embarked on some research on my own, and I came down to four things that, in my opinion, have changed in the last 5 years: who our colleagues are, how we interact, how we cope with information, and last but not least, how the economics of radiation therapy have changed. So, quite a diverse topic list, and excuse me, we're going to run through these topics one by one for today's talk. So let's talk about who our colleagues are. The last few years, we've seen a shift in the composition of generations in the workplace, not just my workplace, but all workplaces, all of your workplaces. And this has been driven by two things. The first one is retirements. The United States Federal Reserve noted that there were two areas driving retirements. The first was early retirement packages offered by many organizations at the start of the pandemic in 2020 into 2021. However, from 2022, the retirement rate has remained above the 10-year estimate. And this is because of the significant returns from the stock market, driving up retirement savings, allowing people to retire a bit earlier. And primarily, of course, this has impacted the traditionalist and boomer generations. The second thing that happened in the last 5 years is the introduction of Gen Z into the workplace. Now, Gen Z entering the workplace is interesting because it's a generation that basically did their degrees virtually due to the pandemic. And this results in setting completely different workplace habits and expectations. We're going to deep dive on this, but the net effect is twofold. Firstly, due to the retirements, now millennials constitute the largest generation in the workforce. And secondly, due to the introduction of Gen Z, for the first time ever, there are now 5 generations active in the workplace. We all use generational terms, millennial, etc. But it's important at this point to pause for a second and think about what defines a generation. Generations are determined by groups born roughly at the same time. But in addition to this, the generations exhibit traits that are general in nature and reflect the social circumstances in which each generation grew up. Think about that for a second. The social circumstances that they grew up. And they were vastly different circumstances for the generations in the workplace at the moment. And this has impacted how each generation operates in the workplace. Of course, while this chart is referenced in research, it is an absurd oversimplification of 7 billion humans on the planet. No one on this call is likely to associate with everything for your generation. But that isn't why we're sharing the chart today. I'm sharing this chart with you guys today to encourage a high level understanding of the characteristics of each generation and perhaps to move away from stereotypes that we sometimes see relating to generations. The impact that technology has had on generations is huge. If you draw your attention to the technology fluency row, we see quite a lot of variation here, which makes sense, right? Think of the advent of the internet, the smartphone, etc. So basically, work is a zoo, it's complete chaos. We have 5 generations who are actually wildly different due to their experiences growing up. And it isn't small differences between colleagues, it can be quite large differences. So here we go. We threw these 5 generations into the workplace and thought, okay, cool, boys and girls, get on with it. Function as a team, even though you're wildly different. Okay, you know what? That might have worked. But at the same time, we did something else. Oh, by the way, at the same time, we're going to change the way that we communicate completely. Which brings us to our excuse me, second section. So 5 years ago, if I'd asked you to jump on a Zoom call, I would have got real blank stares. I'd have tried to explain, like, guys, it's like Skype, but it's a darker blue. There are these emojis. People are going to have their video cameras on, and if you don't have your video camera on, you're going to be the weird one. You guys wouldn't have believed me if I told you that 5 years ago, right? Stuff's changed. Digital communication was amazing. We have multiple ways of keeping in contact, and in countries with strict lockdowns, it kept families together. It allowed my mother to watch her first grandchild grow up for almost the first 2 years of his life. That was a nice side of digital communication. Even on the work side, we applauded those who quickly digitally migrated, these digital savants who seamlessly navigated zeros and ones and dove headfirst into the digital matrix, these daywalkers, right? Who were these mystical people? Well, now we know they were Gen Z, right? Um, but there is a dark side to this. How can I be so tired after a day on Teams calls? Last year, I built a retaining wall. I mean, I'm lifting 80-pound bags of cement. I'm hefting cinder blocks. I'm cutting rebar. This is robust stuff. I'm stressing around, utterly ridiculous, with an angle grinder bolted to my tool belt because, grr. This is exhausting work. Yet the next day, I'm working on my laptop for work. I'm giving yellow thumbs up. I'm pinging people. I'm circling back and touching base. And I'm doing all of this with a very well supported lumbar and an ergonomic keyboard, which I'm going to the vast physical effort of depressing 2.1 millimeters. Oh my God, make this make sense. How can I be so tired? So here's an interesting thing. There is emerging research, seriously, there is emerging research, that we don't basically get the dopamine from digital communications. But we do, right? We get about somewhere between 10 and 17% of the dopamine from digital communications that we do from the same interaction face to face. Now, we do actually get the same or more cortisol from digital communications. We get less happy hormone and more stress hormone. We also don't have these natural breaks between meetings. I mean, fundamentally, we're asking our endocrine systems to whiplash between completely different calls. We're essentially interval training our endocrine systems. And there isn't that much of an upside. If anyone does Peloton or Soul Cycle or whatever, it's like a HIIT program, a high intensity interval training program. for our bodies 9 hours a day. Dopamine helps us bond, it helps us connect, but it also helps us remember. It isn't emerging research. This has been known far before the COVID era. Dopamine essentially makes learning and memory parts of the brain activate more. Remember what we say to kids, learning is kids fun. Learning is fun, kids, right? Well, it is. To be human is to learn. So it makes sense that learning makes us feel good. This is reflected in asynchronous learning. Despite world-class development, it is commonplace to see users complete a small percentage of asynchronous learning courses that they start. The digital consumption doesn't give the same dopamine hits that in-person learning does. And yes, of course, there are ways to drive this up. Social interactions, gamification, all of which are starting to be employed to help with this. Video done correctly is another way to drive up engagement. But we have multiple generations in the workplace who don't just have different technological fluency. We have generations that have, at a physiological level, respond to digital versus non-digital communication differently. We have colleagues who make connections with each other differently at a fundamental level, yet we may not always be considering and understanding that. Not being part of a team of an organization is more fundamental than company engagement scores. It's wired to our sense of tribe that we have evolved over centuries. And of course, things will feel a little bit weird, and perhaps that's okay. Which brings us to point number 3. The next point, the next point is information surplus. So when I get lost in the not too distant thinking about today, I like to do this thought exercise of time travel. I like to jump a few decades into the future and imagine if I was a teacher teaching kids at school about today, how would I summarize that? How would I simplify that? If we were to look back at the time frame 2000 to 2020, we might describe it as the age of information surplus. We have so much information available to us in vast, vast quantities. As scientists, we thought this was going to be amazing. Can you imagine having the knowledge of the entirety of the human race in your pocket? Amazing. The challenge is it isn't just fact. The internet, as we all know, isn't peer reviewed. There are lots of perspectives available to us. Even in our field, we have different perspectives on medical approaches. The inability for us to absorb and synthesize information is inherently human. The simplification of the age of informational surplus is probably one of the most in-demand requirements of humanity right now. NVIDIA stock is sky high because of generative AI. Why? Generative AI can synthesize all of this informational complexity. It is literally the most in-demand solution humanity currently has. It's not the chips, it's not the AI, it's not the algorithms. It's the ability to simplify everything so that our brains can understand better. But how does that impact our field? How does that impact radiation therapy? As so much information, we arguably have the most information of any field in medicine. Yet it's so much information that it's difficult for our minds to process it. Of course, there have been plenty of research putting to use this potential treasure trove of information. But it's only in the past couple of years that generative AI really has been accelerated and become accessible and accepted. Medical technology, in general, given the risks involved in getting something wrong, is a field where new technologies like generative AI tend to lag implementation a little bit. But we can expect to see the application of the technology in the not too distant future. However, this is still to come, largely. It isn't something that has been in widespread use for the last 5 years. In the last 5 years in our field, we have reached a level of incredible amounts of data, so much so that perhaps we have not been able to effectively use or decipher that data. Another area of simplification is financial markets, which brings us to our 4th and final point for today. But before we get to that, let's pause for a second and recap. We have multiple generations with vastly different perspectives on the world. We have fundamentally changed the way we communicate, almost overnight, changing behaviors that have developed on an evolutionary timescale. And let's add to that a massive influx of informational availability, essentially overloading our ability to synthesize information. Oops, sorry, let me get back. So now, on to our fourth and final point, the radiation therapy market. There are thousands of things to look at to determine whether investing in a company is a good idea. Everything from supply chain nuances to intellectual property rights to exchange rates. The Warren Buffetts of the world look at all of this, and of course, they're famous for it. But to the person buying meme stocks on their phone app, perhaps they're not necessarily looking at all of that information. What's happening? Simplification. We have KPIs for publicly traded companies that we often use and frankly form the cornerstones of a company's performance. Simply put, revenue and margin. Revenue basically being how much money that company makes, and margin being how much of that money is profit. And for companies to be successful and grow, that means a continual growth of revenue and margins that are competitive with peers. So we're going to start looking at revenue. And basically, this means sell more. So, how is radiation therapy done historically? Now, I am vastly simplifying this, but bear with me for a moment. Nothing is as clear cut as this, but you get the idea. Where has the commercial focus been for the past few decades? Well, MLCs, driven by developments in mechanical design and manufacturing, provided advancements in the 90s. In the 2000s, it was very much about software, and more specifically, treatment planning software that used microchip advancements and cost availability. By 2010, we were firmly into the imaging being the big thing. See what we are zapping, cone beam CT joined by MRI. So the value offered to generate revenue for the last 30 years is these technological jumps, big jumps, which got us to today, where we have the ability to create the most exquisitely sculptured radiation fields and direct them to exactly where we want them. This whole seek and destroy thing, we're pretty good at it, right? But we aren't seeing the big jumps that previous decades brought. We might ask the question, why upgrade? Why upgrade when the big jump that we saw between perhaps MV and KV or KV and later MR, and we're not seeing those jumps? The benefits are there, but the jump aren't quite as big as they used to be. And this is a problem for a field or a market that's accustomed to big jumps. But there aren't any big jumps. Yeah, we are always improving precision and accuracy, but not in those big leaps. Well, that's depressing, right? Well, kind of yes and no, right? And hear me out on this one. In a good way, we've got to a point where these big accuracy and precision jumps have been made. And that's a good thing. If you're getting treated and you're a patient today, man, that's a good thing. But perhaps there's something else that's happening. Perhaps there's another big jump that is still there, but it's not accuracy and precision. Perhaps the big jump is scale and accessibility. We have great accuracy and precision, but how do we allow more patients to benefit from them? Excuse me. Now let's pause for a minute and highlight something simple but important. Vendors don't sell Linux or CTs or MRs or QAs or whatever. Vendors sell value. In our field, that is the ability to treat cancer safely and effectively. I'd like to introduce you to Paul's occasion of queer reference, frankly, my own brain. If we consider this equation, the challenge for most vendors is that until all of the boxes on the left are ticked, the value cannot be accomplished. And if there is no value, there is no sale. If there is no sale, there is no revenue. If there is no revenue, there is no margin. If there is no margin, there is no company. This is the financial section of the talk, right? From a business perspective, this is a literal existential issue. So what are the challenges with this equation that we see today? Workforce, in actual fact, is the global challenge at the moment. We knew this with the famous 2015 Lancet paper, which told us how many skilled medical folk we needed in radiation therapy in the next 10, 15, and 20 years. And spoiler alert, it's 2025, and we're not tracking towards that. There's another great paper from 2022 on the same subject. In 2019, the American College of Healthcare Executives voted workforce as their number one concern for the first time, and it has remained the number one concern since then. So it seems like the task at hand is solve this equation for workforce. And fundamentally, we can do this in two ways. Number one is increase the workforce impact, and number two is decrease the workforce requirement. And really, this equates to two things. Efficiency, do more with the workforce that we have, make their lives easier. Number two, simplification, require less knowledge from workforce so it's faster to train a workforce. Vendors are focused on making products that are more efficient so that the existing workforce has more of an impact. In addition, vendors are focused on making products simpler so that workforces can be trained faster and easier. And yes, this will likely change the role of the medical physicist over time. So let's talk about that for a bit. What does that mean for the role of the medical physicist? We can expect technology to target automation and efficiency for the simpler tasks towards the bottom of this diagram first, and basically make them go away or make them so you spend less time on the simpler tasks, which gives you more time for the more challenging tasks. And that does require a bit of trust. We have to learn to trust the automation. And of course, we need to verify that the automation is working. We should periodically check to make sure that remains the case. But we do have to switch our mindsets to an exception-based information mindset. We want to know about exceptions in these simpler tasks. For example, only tell me when a gamma analysis fails. Don't tell me if it passes. Just record it and bypass that section of the workflow. Unless I am told that it has failed, it's passed. I spend time on exceptions. If we look at the tasks above, we can expect that compression of the lower tasks. But remember, the goal wasn't to spend all of that time on the upper tasks. The goal is to enable more care for more patients. So even if we automate at the bottom, we still need to maintain or improve simplicity towards the top. I saw a couple of names from product management when I jumped on the call. So I'm going to go slightly off script and throw in a freebie to you guys, a way of getting your design teams to really execute on this. And it's called the so what rule. And it goes as follows. Tell the user, so what? For example, gamma analysis failed. So what? I actually don't care that gamma analysis has failed. I care about the impact that the fail could have on my patient. What would be useful to know is gamma analysis failed. Check leaves 15 to 20. Even then, we could apply the so what rule again. It could tell us to perform some some machine-based MLC checks on those leaves. It could even do this automatically. The so what rule is a very simple way of really thinking about efficiency and getting to the root of what we are trying to accomplish. But back to the main topic for now, and of course, automation and simplification might have some knock-on effects. Yeah, it could change how we educate. It could change the vocational training we provide to medical physicists. I've been in numerous, sometimes very heated debates about the future of the role of the medical physicist. Are we commoditizing the role too much? Are we becoming too restrictive with the role? Was there enough science? After almost 2 decades in this debate, here's the thing. I wonder perhaps if the answer is in our job title, the actual words. It's the strangest combination of words. Let me explain. When we think of the word medical, we desire certainty. We want to know that we will be okay. We don't want to take unnecessary risks with our treatment. We want safety. We want assurance. But then we think of the word physicist. We think of experiments. We think of hypotheses. We think of trying out new ideas. We think of the mad scientist. The role medical physicist is therefore fascinating even in the name. Radiation therapy has advanced so quickly because of the physicist bit, the ideas, the creativity, the brilliance. Yet the relevance and the impact on so many lives comes from the medical bit. It is a role that at its core is split. In my humble opinion, great care should be taken in making sure that the contrast between these two words is preserved. Yes, let's bring automation and assurance to patients, but also let's conserve the creativity that allows us to provide better treatments to patients and to advance the field. Let's zoom back and look at how we ended up here. Basically, for companies to succeed, they need revenue. To get revenue, we need to create value. To create value, we need to solve the care equation. And to solve the care equation, we need to solve the workforce challenges. To solve the workforce challenges, we, excuse me, we need to create this efficiency and this simplicity. Now, recall that we did focus on revenue for the past few slides, but we did say there was another company KPI, key performance indicator, and that was margin. Companies also have to meet margin requirements so that they're competitive in their profitability. Companies can't spend whatever they like to accomplish revenue goals. It would destroy the margin goals. In fact, I'm going to put to you that there are perhaps three generic reasons that margins can be a challenge for manufacturers. Firstly, no surprise, generally things are more expensive. If you do groceries, you'll know exactly what I mean. It's not just $9 blueberries, everything is more expensive. Materials, insurance, salaries, travel. Secondly, we see an expectation in developed markets for better efficiencies. There is increased pressure on pricing in developed markets than there has been in previous decades. And thirdly, we do see a growing demand in developing markets. It's big, but the price points are somewhat lower, and the cost of realizing the value can be high. Now, the price points being a little bit lower, I mean, the clue's in the name. Many developing markets are low and middle income countries. In addition, if it's the first instance of a technology or solution in a geography, it can mean that supporting infrastructure needs to be established as well. Service logistics, support, perhaps a regulatory framework, it doesn't exist yet. And of course, supporting education systems. So advances in efficiency and simplification, absolutely the way to go to drive revenues, but it has to be developed in a financially sustainable manner. All right, final slide, guys. I had opened with a question of who thinks this is a bit weird right now, and from the text that I kindly received, right, the vast majority, or many of you, did raise your hands. In putting together this talk, I have come to realize that radiation therapy is affected by so many things all around us. In this talk, we've highlighted how generational composition and digital communication affects our workplaces within radiation therapy. We have highlighted how information access is challenging how we consider facts and perceptions. We have highlighted how global economics impacts our field and even our roles. To understand the world surrounding radiation therapy is an incredibly broad topic. It's basically saying, explain the world in 45 minutes or so, right? Of course, that's impossible to do. It's impossible to do in a lifetime, perhaps multiple lifetimes. But I put it to you that this really isn't the goal of today's talk. As individuals, we all need to ask questions. And I encourage you to ask questions. The decisions you make based on what you find out are unique to you. There is no magic formula that addresses every person in every institution, in every country around the world. Perhaps the trick to global access might be to answer the questions, for you to answer your questions. What we've discussed today is deeply personal. Right? It's my answers and thoughts that work for me, things that help me personally understand what's impacting our field. I could be wrong. I could have missed something. I could be focusing in the wrong areas. Each of you guys has unique experiences, and incredible intellect and capabilities. You will find your own answers when you start looking. Start seeking to understand the things outside of our field that shape our field. Science, at its core, is about asking questions. And my request to you is pretty simple. The goal of this talk is very simple. The single takeaway that I have with this talk is very simple. Ask questions. All right, guys, it has been a genuine honor